My goal in this video is to walk you through how to use the computational layer in Desmos to make a few basic question types that can provide feedback to you and feedback to students. And so I have this template I've created for example questions. We have questions that have a numerical answer, questions that are multiple choice, questions that require students to order, and then questions that require students to complete a table. And there are a lot of other different types of question types that we can make, but I'm just going to start off with teaching some basics about computational layer and in the process give you some templates you can use. So first off, looking at questions that require a numerical answer. And to be clear here, we're just looking at integers or decimals, no fractions, mixed numbers, things like that. This is just if we were looking at whole, again, integers or decimals, things like that. So first off, these are components, and so I've dragged into here a note component and a math component. I put the note up here, which is what students will see. So again, this is just some basics here. So this is the question. You'll see that's typed out here. And then this bottom component, this math response component, I have named the component. And little trick, if you make a lot of activities, it's helpful to come up with some type of naming convention that you use with all of your activities. That way, you make sure you don't duplicate any of your names for your components, like this is the name for this component. That way, if you want later, you could mix and match your questions and all of your code will still work. So the naming convention I use, up in this upper left corner, you type the name for your component. I give a unit number, a lesson number, a question number, and sometimes something extra. In this case, I just put NA for a numerical expression. A lot of times you'll just see something that looks like that. So some type of naming convention for the component so that we can reference the box where students are typing their answer in. So first thing I want to do is I want to go down here to this symbol over here. Mine is green. Yours is probably gray if you haven't put any computational layer code in. I'm going to click there. Okay, so I'm going to walk you through a couple basics here. So here you'll see check 1 and check 2. So think of these checks as if you're looking at a student's answer and you want to know if it's the right answer, there's a couple things you might look for. So in this case, I'm looking for is the value of whatever they typed, is that 9? And I'm also looking at the second check to see is there just one 9 in their answer. We'll talk about how those work and why I did both those checks. So this first check, think of this as like a yes, no. So check 1, yes, no. It can either be true, yes, their value equals 9, or no, their value doesn't equal 9. So I'm going to write check 1. I'm going to put an equal sign because I want this to check to see if this component, so I'm typing the word this, and in Desmos you can use the word this whenever you're referencing the component that you're putting the code in. So I'm putting, right now I'm in the computational layer for the math box that students are entering. So I can use the word this. So check 1 is going to look in the box that is this one, and I'm going to put a period, and then I'm going to type numerical value. So just to be clear, when you start typing NU, numerical value pops up. That's a very specific Desmos, like it's looking for the number value, numerical value of that thing. And I want that value to be equal to 9. And so what it's going to do in that first check is it's going to check to see does what the student type in, is it equal to 9? So right now, yeah, it is equal to 9, and it's giving me a little check mark here to say that it is correct. I'll show you what that is later. The second check here is to check to see, again, check 2. So this is the second true false, equal to, and I'm going to use count number usage. And to be clear, that is a specific Desmos code phrase. And that we use this when we want it to count how many numbers, how many of a particular number appear in a student's answer. So in the parentheses here, I'm going to tell it where to look. So look in this component. I want you to look for latex. Again, that's not terribly important to know what that is, just looking at the text that is actually in that box. Not looking at it as a number, but as a text. And I want to look for the number 9. So check 2 will count the numbers in this component, and it's looking for the number 9. And I want it to find 1, 9 when it looks in the student's answer. And so it's going to run that second check. So again, when I click students put their answer in, yep, it is equal to 9, and it is the number 9. Now you might ask, okay, why do you need both those lines, right? Why can't the value just be equal to 9? So I'm going to show you real quick. Get rid of a line of code. I'll explain again what this code does in a second. But let's say right now I have it only looking for this first check, right? So this, what I just changed right there, it's only going to check to see is the value equal to 9. So if it's doing that, and I type the number 9, right, that's the right answer. But if I type 4 plus 5, it's also saying that that's correct because, yeah, 4 plus 5 does have a value of 9. And this is why I have two different checks that I'm using. Why I'm having it check the value, and I'm having it check how many 9s appear. Now, you might say, okay, why not just use the second check? Well, with this, if you only run this second count number usage, well, if a student types the number 9 plus 5, it would also think that's right because it's counting how many 9s, and there is one 9. So I run both these checks to see is its value 9 and how many 9s appeared in the expression. Okay, now, in this next line here, and again, I'm still in this component where the math students are going to enter their answer, and I type the word correct with a colon. And when it's green like this is another very specific Desmos like symbol. It's a sync. And so what I'm using this correct for is to tell Desmos have Desmos check whether the answer is correct or not. And where we're going to see that is not actually this. This is something I made. I'll show you later. It's looking at this check mark. And so you'll get the check mark on your teacher dashboard when check 1 and check 2 are true. So it's correct if check 1 and check 2 are true. And you don't have to write true or anything like that. You just type the variable here, check 1 and check 2. Okay. The last piece here is I use disable evaluation. And the reason I use that, I'm going to show you in a second, is Desmos, those math answer boxes, can kind of act like calculators. So if I put 4 plus 5, you're going to see it's populating equals 9 over the right-hand side. And the reason it's doing that is it's calculating. It's telling you what's the value of that. Well, I don't want students to be able to do that. I don't want them to be able to use this as a calculator. And so I want it to disable evaluation. In other words, don't tell the students what the value of what they type in is. So you do disable evaluation, colon, and then true. And that's all you need in the student answer box. And that will, if you just do these lines of code, that will give you the check mark in the upper right-hand corner here, or the X, and it will disable evaluation. Now, how do I get this to say correct or incorrect? That we have to actually do some more coding, and I'm going to code this part in the notes. So this is the note component. I'm going up to this computational layer, and I'm going to click on it. We have a couple lines here. And I generally use this same structure for almost all of my question types. So here you're going to see feedback, and that's a word that I've picked. I want the feedback to be equal to, and then I have some when statements here. So I could type all this in one line. It doesn't matter if you hit enter and there's separated onto separate lines. I'm just doing this to make it a little cleaner for you to see what's going on here. So feedback, whatever feedback is, I want feedback to be a certain thing when, I'm going to use the word when, this, you've probably seen that before, so this component here that I'm referencing, Unit 1, Lesson 1, Question 1, and A, that's looking in this math component. Remember, we named this component a certain thing. So it's looking when what the student answer, math answer box, and I'm going to use .script. So .script is a very specific Desmos phrase. So script is basically saying, I want you to look in the code, look in the computational layer of the script for this component, and I want you to check 1. And so what this line right here does is it looks in the math component and looks for the variable check 1. And remember, we named that. So check 1 is checking what's the value of what students type in. So do check 1, when check 1 is true, and here's that next one. So when this math component is submitted, so when they hit submit and correct the answer, then it will say correct. Now, I'm actually missing my second check here because I was showing you guys something and got rid of it. So I want to just show you how I add that in. I'm going to click and you're going to see it's popping up with all kinds of named components. And I'm going to do check 2. So now when the math box check 1 is true, and when the math box check 2 is true, so this is the count how many 9s there are, and they submit their answer, tell them it's correct. If that's not true, then it goes to the next one. When the students submit their answer, tell them keep thinking. And you'll notice here I didn't say like when the answer is wrong or anything like that, because if their answer is right, it will tell them if it's correct when their answer is submitted. The second line is saying, okay, the answer doesn't have to be right. If they just submit their answer, tell them to keep thinking. Because the code is going to check this first line, and if it's not correct, then it's going to go to this next line. If they just submit their answer, then clearly their answer wasn't right. It'll tell them to keep thinking. And you'll see the text that I want students to see. I put that in quotes because it's a latex script. It's a specific text I want to see. And you could put some of these little emojis in there too if you want. So the second line here is when they just submit their answer, tell them to keep thinking. Otherwise, and I have two quotes here. Now you could put a space there. I'm just going to put them like this. This basically means don't put anything there, right? Leave it blank. And so now the last thing that we have to do is we have to show Desmos where I want them to give that feedback. And so right below the question here, still in this same note box, I'm going to go over here to this little pound symbol. It says insert a value from the computational layer, what we were just looking at here. I'm going to click that, and I'm going to type feedback, or it gives me that option. And so that right here is saying where it's deciding what to say, correct, keep thinking, or say nothing, it's going to put that right here. And I can actually center that just to show you here. So right now, if I give them a correct answer, right, there's where that feedback is. If I move this box, make it in the middle, it's putting that right there. So you can see, think of this as like a variable, and it's going to put in where that word feedback is, whatever you tell it feedback is equal to. Just to show you one more thing here. So here is where your feedback will be. So here I've done, again, if it's correct, say correct. If it's not correct, say keep thinking. Otherwise, just say here's where your feedback will be. And so when I preview it, see how students haven't submitted their answer, so it's just putting this code here, or that text there. So again, I'm going to get rid of that because I just want it to be blank. And now you have a working question. So you'll see the student feedback, you'll see the teacher feedback, it'll tell the teacher whether the student got it right or wrong, and you're off to the races. So that's how to make a numerical expression code. And you also learned some extra CS first code in the process. So this next one we're looking at is multiple choice, and this one is much simpler, but we're going to see some of the same components here. So here I have a note component, but this time I've chosen a multiple choice component. So if you click on it, you can see it pops it down here. So again, in my note component, I've typed what it is I want the question to be, and you'll still see this feedback, which we'll go back and look at in a second. So the question is, which multiple choice option down here shows the sum of 5 and 4. So I'm testing, do they know the word sum? So I've, again, named this multiple choice component. Again, Unit 1, Lesson 1. This time I changed it to Question 2, and I have MCA. Again, almost all my activities, you'll just see a unit number, a lesson number, and a question number. So my multiple choice component, I'm putting my multiple choice options down here, and then I click on the bubble here to select what the correct answer is. Now, I'm going to go into the code, the computational layer, for my multiple choice option. And here you can see I have that same correct, so that's in green, that's a very specific Desmos thing with a colon. And this time I said this, so look in this multiple choice component, period, and see that it matches the key. And the key is me having told it what the correct answer is. And so there we go. That's all I need for that green check mark, or for that check mark to appear. And actually, you technically don't even need to put the correct there, but I just do it because it helps out a little later on. Okay, so that will do that. Going back into the multiple choice computational layer, and I'm going to show the show submit button, because without that, sometimes on these multiple choice options, the submit button appears, sometimes it doesn't, so I just always put that just so that there's always a submit button and students aren't just toggling between options here. Again, sometimes that's something that could be useful. I don't necessarily have to have it this time, but I want the show submit button, I want that to be there. Okay, so that's all I'm putting in for the multiple choice option. And now I'm going to the Note tab. And you're going to see this looks almost identical to the one we just looked at, just with a few tweaks. The one we looked at with the numerical expression question. So here again, feedback will be, I want feedback to be equal to something. So when, this is the multiple choice name, so look in the multiple choice question 2, check to see that it's matching the key. And check that that multiple choice option was submitted. If those two things are true, then show them their answer is correct. When the students just submit their answer, right, so when it's not matching the key, but they did submit their answer, tell them to keep thinking, or tell them their answer is wrong. And then this last one, otherwise, don't show them anything. You again want to make sure you have this value, this variable, if you want to think of that way. You want to make sure that again is right here. So to get that, you hit this button, again, feedback, and it's looking in the computational layer, the code layer for this note to find that word feedback. So now students pick the right answer. The answer is correct. They pick a different one. Keep thinking. And if they don't select any, don't show them anything. Okay, and that's a multiple choice question. Again, that one's pretty simple. Next, I want to look at a question that requires students to order their answers. So this one gets a little bit more tricky. So you're going to see 3 different components here. Here is my note component. Over here is this ordering list component. And then right below here is an action button. So because the ordering list doesn't technically have a show submit option, right? There's no submit button for ordering. I have to kind of make my own. And so this is what the question will look like. So students will drag and put their questions in a particular order, and they hit this button to submit their answer. So a little bit more going on here. I'm going to start off with the multiple choice options. Sorry, not multiple choice, the ordering question code. So I'm going to go to this ordering list. I told it I wanted the students to order from greatest to least. And then I put the values right here as things that could be dragged. You could add more items, longer list if you want. One quick thing that I did here, if you click on these 3 dots, is I told it I want to use the order that it's currently in, that I typed these things in. I want you to use that order as the answer key. So this is the correct answer. When you select that option, it will automatically check the box that says randomize items. Because if you have it in the correct order and you're using it as the key and that's the order students see it in, then the answer is technically already right when students get to it. So it wants to always randomize these numbers. Okay, and I did that with the 3 little dots. Now I'm going to click on Edit Computational Layer. Okay, so this is a lot of code. Don't be scared about it. I would just copy and paste this anytime you're using some type of an ordering question where students are putting things in particular orders. So here's what's going on here. I have this word that I've picked, order, right? That's a variable. And I want that to be equal to, and then I've got a quote right here, and I've got a quote at the very end. And so what it's doing here is it's basically coming up with a number, and that number is going to consist of 1, 2, 3, 4, 5, 6 different items. And so next I have a $sign and this squiggly bracket here. So this part right here is looking where is item 1 at, right? Where is item 1 at? So in this multiple choice component, that's this, dot, find what position this 3 is in. And so this is basically giving me a number, right? So maybe the number 3 is at number 5, position 5. Item 2 is in a different position. Item 3 is in a different position. And each one you're seeing a $sign, squiggly bracket. Look in this component, look for the index of the item, and look for item number 4. And it's doing that for all 6. Now I only have 5 components here, so that 6th one isn't actually doing anything. But if you add 10 items students have to order, I would just copy this and then change it to 7. And just keep adding more items in that list. So get rid of that. Okay, so it's not terribly important to know what this is doing. All it's important is just knowing that it's giving me a number. So it might be like 5, 1, 3, 6, 2, 8, or 4, right? That number. And I'll show you what I'm going to use that for a little later on. So that's all the code that you need in this multiple choice option. And again, order is going to be equal to a certain number that's built through looking at the position of each of these different items, these ordered items, the order that they're listed in. Okay, we'll come back to that in a minute. Talk about why that's important in a second. So next I'm going to look in this action button. Again, the action button, I clicked right here. That's this one right here. Okay, so in the button label, I've had to submit my answer. This is whatever the students will see. I tweaked it a little later on, but you can type in, try me, or whatever you want. Submit my answer. Okay, so I'm going to look in the computational layer for this. Okay, now, a couple things here. First off, I want you to look at this reset on change. So reset on change, this action button has a little built-in timer. So when I click submit my answer, it starts a little timer. That's going to be useful in a second. This reset on change is saying restart that submit button, right? Set it back to 0, set it back to the way it needs to be when this statement changes. And so what is this statement? Well, this is, again, quotes, which means it's looking at it as a text. There's a $sign, a squiggly bracket. This is the name of the component that we're having students order. So you'll see that's the name right here. So look in the ordering list, .script, so it's looking for a code, and look for the word order. So if you remember, in this ordering part, we came up with a certain number, and that number is equal to the order that those components are in. In fact, let me actually show you an example real quick of what that looks like. So you can ignore what I'm doing right here for a second. Order of list is equal to that. Okay. So I just want to show you what's happening here. Okay. So you're seeing 3, 1, 2, 4, 5, and then undefined. So if I change this order, do you see how that number is changing? And the reason that's useful is that tells me when students submit their answer, if they change the order, it gives them the chance to submit their answer again to check to see if it's right now. So it's telling me to keep thinking. If I put it in the right order, they submit their answer, it's correct. And so, again, to be clear, this reset on change is checking the order that the students have things listed in. If that order changes, then reset this action button, this submit button. Okay, awesome. Next, we have this variable I call it submit. And so since there's no submit button on the ordering list, I had to come up with my own. I'm going to call it submit. Submit is equal to this action button. Look at this action button and look how long it's been since I pressed the button. And if that time is greater than 0, then submit is true. If it's not greater than 0, then submit is false. Okay, that's the submit button. And again, so think of it, that's what that's doing. Okay, now I'm going to come back to this in a minute, but just know that this submit is saying true or false. Is the button been pressed, or has the button not been pressed? Now when we look at the note code, right? This is the note. This is where the feedback is going to come. You can see feedback is equal to when the order, so this is the name for my ordered list component, when it matches the key, so when it's in the right order, and here's the name for my action button. So it's 1, lesson 1, question 3, ordering question, submit. So look in the action button. When the script submit is true, right? That's when the time pressed is greater than 0, then tell them it's correct. So is the answer right? Did they submit their answer? Tell them it's correct. Otherwise, when the answer is, or when they hit the submit button, just tell them to keep thinking because the answer wasn't right. Otherwise, don't tell them anything. So that's how you can kind of make a little submit button for an ordering question. Again, what it requires is making this line of code right here. And again, you could make this submit whatever you want. I just use submit because it tells me. Yeah, that's easy for me to remember. Okay, so I'm going to go, again, back to my action button. There's a few more things I want to show you. So we talked about the reset on change. So reset the action button when the order is changed. Next, I have label. And so label, the word label in green is a Desmos specific. It has a colon after it, turns green. That's this text right here. And so because I typed submit my answer in here, by default, it's just always going to say submit my answer. And so if I get rid of this, submit my answer, and you see how it still says submit my answer, right? I don't want that to still say submit my answer, so I'm giving it a specific line of code. And that line of code is make the label for the button when the time, this component's time since pressed is greater than 0, tell them the answer has been submitted. Otherwise, tell them to submit their answer. So it's changing what that looks like. And again, here's an example. It says submit answer. They click it, and now it tells them the answer's been submitted. The other thing I've done here is I'm going to jump down to style. So style is telling me what that press button looks like. And so by default, when you hit submit answer, it changes to answer submitted and it grays it a little bit. You can keep it like that. I just wanted it to white it out. And so what I did is I added this little style component. Again, you definitely don't need this, but when the button has been pressed, so time since pressed is greater than 0, make the button style white. All right, that's whiting out that. Otherwise, make it its default, which is that maroonish, reddish color. And so again, to see what that looks like, now it whited it out. Students can't really hit the button again. But if they change their order, right, that number order code has changed. Now they can submit their answer again. Okay, so that is the style. The last thing is disabled. And so the disabled is disabling their ability to hit the button. So when submit is true, right, so it's looking at submit. When submit is true, disable it, right, disable it. Otherwise, don't disable it. And you'll notice this is all in caps and all in caps, true and false. So it's telling me, do you want disabled to be true or do you want disabled to be false? Okay, and that's again how I just designed this ordering question. So that students can put in any order, submit their answer. It tells them if they got it right or wrong. This X up here, that X is appearing because I told it to use order as the answer key. And so it knows that this is the right order, and whenever students have in the right order, it will give me the X for the wrong order, and it will give me a green check mark or a check mark for a correct answer. Okay, and that's the ordering question. Again, that one's a little bit more complex. Is what if you have a table that you want students to complete? So this is what the question looks like. So students can type numbers in here and hit submit. Okay, and what I've done here is to show them which table cells are correct or incorrect, and it tells them whether the whole thing is correct or incorrect. That's what I've built here. And so I have a note component here. I dragged out a table component, and then I have another action button, and that's down here in the bottom. Just a reminder, you want to make sure you name your components. It's not terribly important right now, at least, to name your note component, but the table you want named and you want your submit button named. And you'll notice I use my same naming convention. Here I have like complete table. And then for the submit button, it's important to have a different named component. So I add the word submit to call my action button the submit button. Or that's the name of this component. Okay, so we're going to start off in the table. So I'm going to go to the table. You can fill in your values here. Importantly, I have labels at the top. And I did that by clicking these 3 dots, and you'll see headers at the top. Now you could do headers to the left, but just keep in mind that's going to change a little bit of the code here. So I'm going to keep my headers at the top for now. I'm going to look at the computational layer. Okay, a lot going on here. I want to show you a couple things. So first off, I'm going to start with this word reset. And so reset is, again, it's a true-false statement. Or, yeah. So, reset, not true-false statement. It's a variable. So reset is equal to when this, so I've got quotes, so when this table, when the cell numerical value of 3, 1, so that is row 3, column 1. So look to see what that value is, and look to see in this table what the cell numerical value of the 4th row and the 2nd column is. And that's going to spit out a number. And that's going to be useful a little later on. Just remember that this line is giving me a number, and that number is equal to, reset will be equal to the number of whatever the first grade box, so row 3, column 1 is, and what row 4, column 2 is. Next, I have this word correct, and you're going to notice I have this in all caps. Caps isn't terribly important, but you're going to notice it's not green like this one. That's because Desmos is just treating this like any other variable, like the word reset here. And I decided to come up with that word correct. So correct is going to be equal to, or it's going to be true, sorry, it's going to be equal to this cell, so this table, cell numerical value, row 3, column 1 is equal to 5. And it's going to be true when this table, the cell numerical value of row 4, column 2 is equal to 40. And so these are the correct answers to my table. So if I actually go here, right, this function is times 4, so 2 times 4 is 8, 3 times 4 is 12, 5 times 4 is 20, and 10 times 4 is 40. So it's checking to see, is this third row, first column 5, is this fourth row, second column 40. Now, you're probably wondering why I said 1, 2, 3, because it doesn't view this top row as a row. Those are the headers. Importantly, that's because I told it that that was a header. If you use left, or if I were to turn this off, that would change how it counts rows and columns. Okay, so this is giving me a number. So reset is what's the 2 boxes put together. Next one is correct is going to be true or false. Correct is true when that one box is equal to 5 and that other box is equal to 40. And then I have correct, and this is that Desmos specific. This is what gives you the green check mark, or the check mark or the X. This question is correct when correct is true. And so just by typing the word correct, it's checking, is this variable true or false? Is this a 5 and is this a 40? Okay, that's going to give me just the gray X or the gray check mark. Okay, so right there, got a couple things done here. There's 2 more parts that I have here, and this is cell suffix. So cell suffix is a specific Desmos thing. It's going to put a suffix, so an ending, in the third row, first column. In other words, it's going to put it in this box right here. And so what I did here in that line of code is I'm basically telling it, let me space this out a little bit for you, put in that box when this table's cell numerical value for the third row, first column is equal to 5, and the answer is submitted, we'll talk about that in a second, then give them the green check mark. If their table is submitted, give them a red X, because the answer wasn't correct, otherwise it would have done this first line of code. Otherwise, don't show them anything. And so that's where we're getting this little green check mark. Okay, that's what that line of code is doing. It's giving me a little symbol so students can, have a whole table complete, and it tells them that maybe they made one thing wrong, tells them the question is wrong. This way they're getting feedback on what specific parts of the table are correct or incorrect. And that is for that cell. And then this is the same line of code as this one, except it's doing it for that other empty box in the table. So it's putting a suffix in row 4, column 2, when the cell numerical value is equal to 40, and their answer is submitted, green check mark. When their answer is submitted, red X, otherwise don't show them anything. Okay, and that's again just going to give you these suffixes, or these suffix, suffix, this little symbol here on the right side of the table. Okay, now you need to also have this action button that I put here at the bottom. You need that to make what we just did work. So I'm going to click into the computational layer for the action button. Here you see that variable submit. Again, you could type whatever word you want to type in there. You just have to remember what it is. So I use the word submit as that variable. So submit is true when this action button has been pressed, and that the time since it was pressed is greater than 0. In other words, did they press the button? So that's the submit. So when we go back into this table for a second, remember we had in our suffix where we're getting our green check marks and our red X's, it's checking the value, but it's also checking that we submitted the answer. And so here you see the name of the action button. So this is the name of the action button. So look in the action button, look at the code, and look to see that submit is true. Look to see that the time pressed is greater than 0. And again, I use that same reference code here for the second cell. So back into my action button. That's what this line is doing. It's a variable. It's checking to see they press the button. A couple other things here. You see reset on change. So whenever this text changes, it resets the action button. And this is the same as the ordering question we did earlier. So this text, whenever this text changes, reset the action button. So remember, this is the table, name of the table. Look in the code and look at the word reset. And if we look back at our table, remember we said that reset is equal to whatever the first box is and the second box. Put those as text. And that's how you do a little reset. Because if you don't have that, if you don't do this reset on change, what ends up happening is students can submit their answer and then they can just keep trying different answers until they get it right. And they don't even have to hit the submit button. It's just going to, they can just keep typing different answers, and this little suffix will keep changing from a green arrow to a red X. So they could kind of guess and check, and we don't want that to happen. Okay, back to the action button. So that's the reset on change. Next is the label. We talked about that in the ordering question. So set the label, set the action button words to when the button has been pressed, their answer's been submitted. So it shows that text. Otherwise, show them the text submit answer. I also disable the button. So when submit is true, so when they've pressed the button, disable the button. Otherwise, don't disable the button. And again, I have style here. So I use this Desmos word style with colons. When the button's been pressed, make it white. Otherwise, make it its default maroon. Okay, and that's going to give you your action button here, your submit button. So far we've done the table, and we've got our submit button working. Last thing we're going to do here is the note. I'm going to go into the notes. So here's my feedback. I'm going to go into the code there. And this is very similar to what you've seen before. So feedback is equal to when the table, look in the table, look at the code, and when correct is true, and look at the action button, look at the code in the action button. When the code in the action button, when the word submit is true, show them their answer is correct. When the action button code is true, so when the time since pressed is greater than 0, tell them to keep thinking. Otherwise, don't show them anything. And so one quick note, the reason I'm using in my table, the reason I'm using this word correct, because you might say, why not just put this, since this is what correct is, why not put that here next to the colon correct? Because I'm referencing this variable I've come up with, right? This is either a true or false statement. So it's true when the first cell is equal to 5 and the second one is equal to 40. That way, when I do my feedback here, all I have to tell it is, hey, go look at that variable. Is their answer correct, right? Are both those things true? Or are they both not true? And so that's what's checking here. Is the table correct? And is the action button pressed? And if that's true, tell them they're right. If the action button is only pressed and the table is not complete, tell them to keep thinking. And just as a reminder, make sure you have that feedback here. And again, that is a very specific word I use. So I came up with this word, I use this word feedback as my variable. And so it's going to change what's in place of that word feedback depending on my conditional statements here. So that's the correct keep thinking or nothing. If you don't have that word feedback or that variable there, when you type the answer, when students type the answers, and they hit submit, you'll notice nothing's popping up here because it's not listed as what's in that note box. Okay, and that should be your completing a table type question.